Let's try to do a definition of the derivative question again, but this time with this function. It's going to be, the algebra might be a little bit harder this time because we're going to have fractions on top of a fraction, and we need to remember how to handle that. So let's see how this goes. So let's recall the definition of the derivative. It's defined as the limit as h goes to 0 of f of x plus h minus f of x all over h. So the first challenge is, what do you replace f of x plus h by? We know what to replace f of x by, right? Because f of x is 1 over x plus 2. So we're going to replace f of x by 1 over x plus 2. But how about f of x plus h? What should we put in place of that? Well, I like to think of it as f of anything is 1 over that thing plus 2. For some reason, we're going to be doing x plus h. So let's put x plus h in there. So on the right-hand side here, wherever I see an x, wherever I see a copy of x, I'm just going to replace it by x plus h. When I do that, it's going to become 1 over x plus h plus 2. So that's easy. And like we said, f of x is just 1 over x plus 2. And it's all over h. So here's this kind of double fraction that I was talking about. How do we handle that? Notice I keep writing my limit sign in front. Well, I'll just do some scrap work over here. Do you guys remember this important rule that, well, first, how about this? Let's get a common denominator on this part. Let's just focus on the top here. This over h, we'll worry about that stuff later. Let's just look at this fraction minus this fraction. How do we get a common denominator there? Well, what if, why don't we just review in general a over b minus c over d? How do you combine that into a single fraction? Well, first you kind of have to think about what the common denominator would be. The common denominator in this case would just be b times d. So we need to have that on both of those denominators. Now the way to think about it is this. If I'm at b, how do I arrive at bd? What I do is I multiply by d, okay? And if I multiply by the bottom by d, I also have to multiply the top by d. And when I do that, I now know what my new numerator is going to be. It's going to be a times d, right? Now let's apply the same idea here. It was d, but I want to now make it into bd. So what do I multiply d by to make it into bd? Well, that's pretty obvious. I multiply by b, right? If I multiply a fraction, either the top or the bottom by a number, I have to multiply both the top and the bottom by that same number in order to preserve the fraction, so it's still the same, all right? So the top is going to be here, well, c times b. How about I put it in alphabetical order and write b times c instead? It's the same thing, right? So that's the first, that's important that you understand that little step there. And now we can write it with a single denominator, ad minus bc. Some people just remember a formula and they just go directly from here to here. It's like a times d minus b times c all over b times d, right? You can do that if you want, but it's really important you also understand this method of getting a common denominator, okay? So how about this? Let's just kind of think about it with the formula. It's a times d, so 1 times x plus 2 minus 1 times x plus h plus 2 all over b times d, so this times this. It may look more complicated now, but we really do want to go in this direction. And I'm going to keep these brackets here just to emphasize that, like right here, this is kind of our main fraction line, right? And on top of this main fraction line, we have another fraction. And on the bottom, we have h. And we can consider h as a fraction as well by putting it as h over 1, right? Now, let's see what happens. Well, we need to remember another important rule of algebra now. What if we have one fraction over another fraction? Just as we do here. A over B, main fraction line, C over D. Here, this is my main fraction line. Well, you know, if you think back to, what is the fraction line really means divide, right? So it's A over B divided by C over D. And if you think back to grade school, how do you divide fractions? You change it to multiply, and you multiply by the reciprocal of that second fraction, right? So it's like A times D over B times C. So I like to kind of think that the D comes up to the A and multiplies, and the C goes to the B and multiplies, okay? Let's apply that principle right now. So I want to make this into a single fraction, just like this is a single fraction, right? It's not like we started a fraction over another fraction. I want to simplify it like that, this expression using this idea here. So it's going to be, this is kind of like my A up here, my B, my C, and my D, right? So I got to multiply these two. So 1 times all of this stuff, and I'll just leave that, because multiplying by 1 doesn't change anything, right? And that takes care of the top. And the bottom is just B times C, right? So x plus h plus 2 times x plus 2 times h. How about I write the h in front? And now I have a normal looking fraction. So that's what I wanted to achieve. Now the top definitely can be simplified, the numerator. Let's see, what do we get? Notice I'm writing my limit sign. You know, multiplying by 1 here doesn't do anything, so I just have x plus 2. And what about this? Did I just do everything correct here? Do you guys agree with this statement? Pause the video and see if you agree with me or not. This is actually wrong, okay? Why? Because do you see these brackets here? This minus 1, it kind of multiplies onto all of those. So it's not just minus and then x plus h plus 2. It's minus 1 times x, which is minus x. And then minus 1 times h is minus h, right? And minus 1 times positive 2 is minus 2. So if you miss those kind of algebra things, you're going to be in trouble. Now, as usual with these definition of derivatives questions, after you simplify everything, you're hoping for some really nice canceling. In fact, everything on the top without an h in it should disappear. Let's see if it does. The x's go, because we have plus x and minus x. And we have plus 2 and minus 2, those cancel. And we're left with minus h in the numerator. And what we expect after the canceling in general is to have some canceling of h's, because then we won't have an h in the denominator anymore. And we have that occurring right now, don't we? This h cancels with this h. What do I have left over in the numerator? Negative 1, right? And on the bottom, I just have x plus h plus 2 and x plus 2. Now, you know, in the denominator here, there is an h floating around, but it's irrelevant. It doesn't affect my ability to put in 0 for h now. Everything is going to be defined. So I drop my limit sign, and I replace my h by 0. Notice I couldn't do that on these previous steps. Like, for example, you know, like right here, I have h in the bottom, right? And same with here and here. So if I put 0 in there, the entire bottom would become 0, and then I'd have an undefined expression. But finally, after I have this nice h canceling, I am then allowed to put in h to be 0, and we arrive at a good answer. So this is really x plus 2, right? And there's another x plus 2 here, so this is x plus 2 squared. And there it is. So the derivative of the original function there is equal to negative 1 over x plus 2 squared. You don't have to, if you're not there yet in your course, I would just like to just quickly say a little remark here. How do we do this derivative with using the rules of derivatives? We could use quotient rule, but I would rather do just a little trick. Just write it as this, and then use chain rule. If you haven't done chain rule yet, just ignore what I'm saying here and maybe come back to this later. But if you do know chain rule, you can get the derivative quite quickly, right? It's negative 1 x plus 2, negative 1 minus 1 is minus 2, times the derivative of x plus 2, which is just 1, right? And this is exactly what we just got, right? Negative 1. When I have to the power of minus 2, if I bring it to the bottom, it'll become to the power of positive 2. And timesing by 1 doesn't do anything. And that's the same as what I had down there. But remember, if this is a test question and you do it like this, you'll get 0, because this is finding the derivative by using the rules of derivatives. But if they explicitly tell you to use the definition of the derivative, you have to go through these steps that we did here. I just did this kind of for a check. And it worked out, so we're good on that.